Well, hello students, it's Mr. Rich. It's another Mr. Rich Q&A. It is President's Day weekend, so kind of a light crowd tonight, but I am going to go over some AP Precalc material that I think will be helpful to the AP Precalc students. Some of my AP Precalc students have already advanced into I think it's lesson 3.10, which is on solving trig equations. Some of you are about to get into it. So I'm going to show you what this is all about and how to use your knowledge on the unit circle and your knowledge of the graphs of the trig functions and how to solve these equations. And I think you'll find this extremely helpful. I will share my screen and we will take a look at some problems. Well, we're going to dive right in and show you what these problems are all about. So you've been doing algebra right now, probably 5 years of your life, 6 years maybe. And basic solving equations is all about finding the value of a variable in an equation. And what we do to find values of variables in equations is we do inverse operations, right? You do addition when you need to get rid of subtraction. If you have multiplication done to your variable, then you reverse it by doing division. Well, the same kind of things are going to apply here with these trigonometry equations, where I have equations involving sine, cosine, tangent, or one of the reciprocal functions. I am going to be trying to isolate the trig function, and then I'm going to work the problem backwards and think about what angle must be true for the equation that would make the sign, in this case, equal to the number on the other side. Okay, so what we're going to do is, well, let's first look at the instructions on this first equation. It says solve each equation for 0 less than or equal to theta less than or equal to 2 pi. So they're saying find all the angles theta in between 0 and 2 pi, including 0 and 2 pi, that would make this equation true. Now, the reason that they are limiting you from 0 to 2 pi in this case is that there are infinite solutions most often to these equations. Because if I find an angle that would solve that equation right there, I know that a coterminal angle found by adding 2 pi radians would also be a solution. And then add another 2 pi. So there's an infinite number of solutions to these equations, unless there are no solutions, which could be the case. All right, so what I'm going to do here is I'm going to first start the process by getting rid of the 6. So I'm going to divide by 6 on both sides. And you're going to see why it's important for you to know the unit circle, right? Because if you don't know the unit circle, then these are going to be next to impossible. Sine of theta now is equal to, if I reduce 3 over 6, I get root 3 over 2. So now I'm ready to ask the question, what values of sine, or I should say, what angles in the unit circle give me a sine of root 3 over 2? And you know that the sine values are the y values. So I'm really asking the question, where over there on the unit circle do I find root 3 over 2 as a y coordinate? Well, you could either visualize it or you could draw on scratch paper that if the sign is positive, you are in the first or second quadrant. And where do I find angles when I take their sign? It's root 3 over 2. I know it's going to be these two right here, because that first one there, which is 2 pi over 3, that coordinate is negative 1/2 comma root 3 over 2. This one over here is 1/2 comma root 3 over 2. So my answer to this is two answers. It is at the angle of 2 pi over 3 and pi over 3. Okay, pretty straightforward. We're using our unit circle in reverse. We're saying, oh, I got the answer, I got the coordinate, but let me find the angle at that coordinate. Do they get harder? Oh yeah, of course. Let's take a look at this one. Well, this is 4 cosine squared theta minus 2 cosine theta. So we got to rely on our knowledge of how we generally solve equations that are not linear equations, right? You could think of this equation we just solved much like if it was a linear equation. For example, what I mean by that, I know sine theta is not a linear function, but if it wasn't sine theta, but it was x, right? 6x equals 3 root 3. I would divide by 6 and I isolated the x and I'm good to go. I divided by 6 and isolated the sine, so I could then just simply go I could simply go to my unit circle to find where the y coordinates are √3/2. But over here, it's not that simple because I can't just isolate cosine. Just like if I had said, hey, I want you to solve for x squared minus 2x equals 0. Well, hopefully by looking at that, you know that the technique that you would use would be to factor it, and you could factor out a greatest common factor and then set each factor equal to 0. Well, that's exactly what we're going to do here. It's just that our greatest common factor is a 2 cosine theta. And when I pull a 2 cosine theta out, right, don't forget, cosine squared means cosine theta times cosine theta. So that will leave me a 2 cosine theta and a minus 1. And just like I do when I'm regular equations or polynomials, I use what we call the multiple or the what do we call it? I forget what we call it. The name always escapes me, but it's the idea that when you multiply two quantities and they're equal to 0, the only way that equation could be true is if one of them is 0. All right, so we call it the zero product property is what I was thinking of. The zero product property. Two things multiplied equals 0. It means that one of them had better be 0 or the equation couldn't possibly be true. So we set both of those factors equal to 0, and now I'm going to solve them individually. Dividing by 2 leaves me cosine theta equals 0. And then I think, gee, where in the unit circle between 0 and 2 pi would cosine be 0? Well, I know where that is, right? That's where the x coordinates are 0, and those x coordinates are 0 at pi over 2 and 3 pi over 2. Okay. The other way to think about that, just so you know, picture the cosine. You could use the unit circle, or you could picture the cosine function. That's cosine. When is it 0? Right here at pi over 2, right here, 3 pi over 2. So those are two solutions to our equation. When I try to solve this other factor that has been set equal to 0, I get cosine theta is equal to 1/2. Now I have to think about where in the unit circle would I be so that cosine is 1/2. Well, cosine are the x coordinates, so it's going to be in the first or fourth quadrant. So visualize it or sketch it. When is cosine a 1/2? It's going to be at this location and this one up here, right there. And that's going to be, because I know the coordinates right there are 1/2, comma, √3/2. And that one is 1/2 negative √3/2. So the two solutions that I come up with from that are pi over 3, and this guy down there, 5 pi over 3. There are 4 solutions to that equation, and there they are. Okay, let's keep rolling. Do they get harder? Oh yeah, they get harder. Still, let's talk about finding the approximate value using a calculator. All right. You might think, boy, that's going to be easy using a calculator. No, actually, it's going to be a little bit harder, believe it or not. It's going to be harder to determine what that other value is, because the calculator, when we use it, it's only going to give us one of the solutions, and then we got to figure out mathematically what that second solution is. Let me show you. When we solve this for sine x, we will subtract 5 on both sides, and then we'll divide by a -4. What we're going to do now to solve for x is we're going to take the inverse sine function on both sides. We were really doing it up here as well, but we're going to have to use our calculator to tell us what the answer is by telling it to find the inverse sine of -3/4. Well, the calculator is going to return one value. Oh, and I need to be in radians mode, and I am, because these answers need to be in radians. How do I know? Well, because they said the answers need to be between 0 and 2 pi, not 0 and 360. Although sometimes it's easier to think about things in degrees than radians when we're trying to figure these things out, and I'll show you that. Anyways, let's take the inverse sine of -3/4. That's negative point. It tells me it's -0.848. Okay, so one of the answers to this is -0.848 radians. Now, why did it give me that, right? Why didn't it give me the value all the way around? Because that would be in the fourth quadrant right there. Now, why did it not? Well, if you guys have already looked at the unit for the inverse trig functions, you'll know the answer to that. But at this point, I don't want to go into why the calculator gave us that value. I just want to go into the fact that I can't give an answer of negative 0.848 because those answers have to be between 0 and 2 pi. So I have to find the coterminal angle to that would put it between 0 and 2 pi. So I need to add 2 pi to this to get the equivalent answer. So that tells me that the coterminal angle to this is 5.435 radians. I'm going to draw a quick sketch here. Now, remember, we knew that the sine is negative 3/4. So both of these angles that I'm looking for are below the x-axis because sine is the y-coordinate. So we know that we're in the third and fourth quadrant. This angle that they just gave us was 5.435. So it's somewhere over here in the fourth quadrant. I'm just going to draw it at a random location. That means that the other angle I'm looking for is this one right here. So what we just did is we determined that this angle clockwise is 0.848. Therefore, this angle that I'm looking for over here, which would be this number of radians, is going to be found by taking pi plus 0.848. And so that other angle that is over there in the third quadrant has to be 3.990 radians. Okay. Now, hopefully you're not too fuzzy on why it is that I came straight across, because whatever this y coordinate is, that y coordinate is negative 3/4, right? That's the sign over here. So therefore, I'm looking for another y coordinate that's negative 3/4. Well, it'd have to be straight across to keep the same y coordinate right there. And therefore, that angle and that angle, those two reference angles, we call them, that are made with the x-axis, they have to be identical. So, and the angles that I want to report are relative to 0. So I have to go all the way, rotate around, and that's pi plus 0.848. All right. I hope that was helpful. Let's do one more of those. We have a tangent squared and a tangent. So it looks like this is going to be another one that we'd be factoring well, no, let me show you that we have not done one like this. But this does look like a quadratic. So what I'm going to do is I'm going to bring that 15 over. And this is what I would call a it's a quadratic type equation, right? It's not a quadratic, it's not x squared, it's just tangent squared, and then a tangent, and then a constant. But I am going to factor it into the product of two binomials, because the tangent x would come about from a tangent x and a tangent x. Two numbers that multiply to be negative 15, but add to be 2. I know what those are. It's plus 5 and it's negative 3, like that. I'm going to set each of those equal to 0. So I get tan x equals 3, and I get tan x equals negative 5. Well, let's find the value of the angle that goes with 3. So in other words, what angle has a tangent that's equal to 3? So I'm going to take the inverse tangent of 3 on my calculator. Should be in the first quadrant. Yeah, 1.249. The first angle that we got is 1.249, like that. Now remember, if you're trying to figure out what quadrant these decimal radians are, don't forget pi over 2, right? Pi, let's just call pi approximately 3, right? 3 pi over 2, 3 over 2. So that's like a little less than 1.5. We'll call it like 1.4. This is pi, it's 3.1. This is 1.5 pi. So what, maybe 4.6? And then this is 2 pi, maybe 6.28. So 1.249, I'm in the first quadrant for sure. Now, there is going to be another angle. Tangent is a little bit easier to find these angles, because I can tell you this, that when you're looking for the other angle that has the same equal to 3, it's going to be 180 degrees or pi radians away from that one. So you're either going to be adding or subtracting pi to get to that value. Here, since I'm in the first quadrant, I would be adding pi to that. So I can just take my calculator and add pi to this answer. and it's going to give me another solution, 4.391. Now I'm going to do tan x equals -5. I'm going to take the inverse tangent of -5, -1.37. 3. Go out to 3 decimals on these. That is definitely a fourth quadrant angle. Tangent is going to be negative down in the fourth quadrant. So that means then that we're down here somewhere, -1.3. Remember, this is about 1.5. This is, if I'm rotating clockwise, this would be -1.5. So it's probably a little bit closer, probably down here somewhere, like around here. All right, well, the other one's going to be up here in the second quadrant, up here. But remember, I can't leave this as 1.373. That they gave me an angle rotated in the fourth quadrant. So what I need to do, first of all, is add 2 pi to that. Did I do that? I'm thinking that I did this wrong up here. No, I did. I added 2 pi to that. Okay. Yeah. So to find the coterminal angle, we are going to have to add 2 pi. So let's take that answer plus 2 pi to get the coterminal. So 4.9. So we're going to call this angle, we're going to change it and say the first solution in the fourth quadrant is 4.910, rounding it to 3 decimal places. And then what I'm going to do is I'm going to subtract pi to get the one that's on the other side of it directly across in the second quadrant. So now we will say minus pi, and there's our answer. That is our next answer. So 4 answers to this problem. These 2 that came from one of the factors in my kind of quadratic type equation there, and then those 2 came from the other factor. I'm going to check my answer here real quick. And actually, I don't think I can because I don't think I have the solutions. I don't think I'm even in the, am I in the practice section? No, I can. We can check them down here because we're in the corrective action. So let's check our answers on number 4. Okay, 1.768. They did 4.909. They just truncated it, right? I rounded it. They truncated. That's perfectly fine. And then the other one was 1.249, 4.390. Yep, we got it. That's how we do it. Now I'm going to show you. My original plan here was to do some algebra 2, but I'm going to keep going here with AP Precalculus for this whole session. I only have one student here, and she is an AP Precalc student. And I think the algebra 2 students are going to be fine. So we're going to keep going on here, and I'm going to show you how to do these inequalities. These are not for the faint of heart, right? We're going to have to really think about how to do these problems here. But I am going to take the initial same approach as I did in the other problems. I want to isolate the sine x here. So I'm going to subtract the 2 and then divide by 2. So I'm going to get sine x less than -1/2. Okay. Now, I need to find all the angles whose sine is less than -1/2. So in order for me to know that, I want to first find out, where is sine exactly -1/2? Well, I know that it's going to be in the third and fourth quadrants. How do I know that? Well, 2 ways I know that. I know that obviously from the unit circle, when sine are the y coordinates, where are the y coordinates negative? Below the x-axis, right, in the third and fourth quadrants. But, there's another way to visualize that too. Don't forget, sine takes that characteristic shape. When is it below, when are the sine values negative? From here, pi out to 2 pi, right? So I want to first, before I show you the solution to this, I want to show you on this graph over here, where the functions or where the solutions are going to be. Because when you consider what sine looks like, so I'll make a somewhat accurate graph of sine. Reaches its maximum, back to the midline, down to the min, back to the midline. So our function takes this characteristic shape. You guys know this. And remember that when you graph sine like this, the y values here are the sine values, right? We plotted all of the sine x values on the y-axis, okay? Even if this was cosine, this is one of the things that will confuse students to no end, is over here, when I draw the cosine on this, they're saying, well, but I thought the cosine was the x-axis values. No, you still over here, if I'm plotting cosine x, The y coordinate values here in this graph are the cosine values. The x-axis values are the angles at which we're plotting the cosine values. Okay, so don't get that confused. But at any rate, would you not agree that right there would be -1/2? If you come over this angle and this angle is where sine is equal to -1/2. And this question that we're trying to answer is, when is sine, for what angles is sine less than -1/2? Well, below -1/2. It's all of these angles right here from whatever that angle is, and whatever that angle is, between those two angles, that's going to be where sine is less than -1/2. Well, therefore, the only thing we really need to know to solve this problem is to know when is sine exactly -1/2. Our unit circle is what's going to tell us that. And it is going to be, when you consider your unit circle in the fourth quadrant, it's going to be at these 2 points right here. Because at this point, my coordinate is -√3 over 2, comma, -1/2. And then this point over here would be √3 over 2, comma, -1/2. So those are the two angles. And I know what that angle is. That's 7 pi over 6. I know that that one is 11 pi over 6. So when I'm looking at this right here, this angle happens to be 7 pi over 6. This one over here is 11 pi over 6. So the solution to this inequality would be the interval. I'll write it two ways. It would be all the values between 7 pi over 6 and 11 pi over 6. And notice they told me to constrain our solutions only to be within the unit circle, right? There would be a whole nother interval if I added 2 pi to both of those values of 7 pi over 6 and 11 pi over 6, but we are just only considering the angles within the first unit circle. It is a less than, not a less than or equal to, so I need to leave that without the or equal to. And I could write it in interval notation as well, like that. All right, let's move over to the cosine, and let's do an inequality over here. Right, so you can tell that if you don't have a really good, strong command of the unit circle, these are sort of a nightmare. Just like pretty much everything in this unit, from here on out, without the unit circle, things are really, really tough. And it's not just about memorizing the unit circle, it's understanding the unit circle. It's making a connection between the unit circle and then the graphs that we're looking at here for sine and cosine. Let's go ahead and isolate cosine. We will subtract 3, which gives us a -1, like that. And we will divide by 2. And that gives us cosine x greater than or equal to -1/2. All right. Well, is that right? -1, yeah. So then I want to know, when is cosine greater than or equal to -1/2? Well, let's consider what the cosine function would look like if we were looking at it graphed over here. It starts at 1. It's going to go to a minimum of -1, but it'll start up here, go to the midline, go to the min, back to the midline, back to the max. So it's going to take this characteristic shape. We're talking about, when is it greater than -1/2? Well, here would be -1/2. So there are some values, some angles at which cosine will be -1/2. But it looks like if I'm looking for values where it's above -1/2, it's going to be more than one interval. It would be the interval of values here and over here, over to 2 pi. So from 0 to whatever that is, just beyond pi over 2, it looks like, which you probably could figure by looking at this picture. It's a somewhat, accurate sketch, that it looks like it's probably going to be 2 pi over 3. And it is, right? Where is cosine -1/2? Over in the second quadrant at 2 pi over 3. So this angle right here is the angle 2 pi over 3. And where else is cosine equal to -1/2 in the third quadrant? It is over here at 4 pi over 3. And therefore, I'm going to give two intervals for which this is going to be true. It's going to start at 0. It will include 0 because this is an or equal to. So it's going to be starting at 0 Really, the reason it's not that it's greater than or equal to is why I have that there. It's that my interval over here that they wanted me to restrict myself to was x greater than or equal to 0. So that's why I have to be inclusive of 0 with that bracket. Then I'm going to go over to 2 pi over 3. And now that will be inclusive because of the fact that it is greater than or equal to negative 1/2. And then the other interval is going to start at 4 pi over 3 and it's going to go to 2 pi. And that's also going to be inclusive for the reason that when you looked at the interval, they told me to include 2 pi. Now, just a bit of a warning on that. Almost always when they are restricting you within the unit circle, they are not inclusive on 2 pi. It's usually 0 less than or equal to x less than 2 pi. That is usually how on AP questions that they give you the confinement to the unit circle. They are not inclusive of 2 pi because why would we include 2 pi? It's coterminal to 0. So it's usually not inclusive. In which case, if that were true, then I would not have been inclusive of 2 pi. I would have used a parentheses right there. But that is how those inequalities are done. Very highly recommend, and let's check our answer there first, 10 from 0 to 2 pi over 3 and 4 pi over 3 to 2 pi. But yeah, so I really highly recommend when it comes to these inequalities that you don't try to solve those without sketching the graph of the function. It's going to be very helpful for you to keep it straight in your mind what you're looking for. Now, could I do this with just the unit circle? Suppose I was like not going to sketch that. When we say that cosine x is negative 1/2, that can be done on the unit circle as well, in terms of like where are these angles that are greater than or equal to negative 1/2. So here's your unit circle. So what you would do is you say, where is cosine negative 1/2? You would say, oh yeah, it's here. No, sorry. You know what? That's it. Yeah, it would be here. Cosine is right here, but it's also down here. So think about that. This is where the x coordinate is negative 1/2 because cosine, excuse me, cosine are the x coordinates on the unit circle. So therefore, this is the angle right here, which happens to be 2 pi over 3, where cosine is negative 1/2, and here's the other one. Now, to be greater than negative 1/2 means that you have to be this way on the x-axis over to here. Those are the x values or the cosine values that are larger than negative 1/2. And so it's really all of these angles and all of these angles. But I can't give them as one interval because I can't say that it goes from 4 pi over 3 to all the way around. I have to give it as two intervals. I have to give it as the interval from 0 to 2 pi over 3, and then from 4 pi over 3 to 2 pi. But again, you can do the analysis on determining where these angles are that are greater or less than a value, either on the sketch of the graph where you've graphed the x coordinate to be the angles, or you could do it on the unit circle. You just have to remember that if I'm dealing on the unit circle, my cosine values are the x coordinates. Let's do the same analysis on the unit circle as we did over here on the sine. So I'm going to, we know our answer there. Let's pretend we weren't going to use this and we were just going to say, let's do this analysis on the unit circle. So we know that we're trying to find when is sine negative 1/2. Well, we did find out sine is negative 1/2, right? Because the coordinates over here, that coordinate, I should say, is negative √3 over 2, comma, negative 1/2. And here's the other one over here, which would be √3 over 2, comma, negative 1/2, right there. And we're trying to find out when is sine less than negative 1/2. Well, but sine are the y values. This is where sine is negative 1/2. I'm dealing now on the y-axis, whereas on the cosine problem, I was looking at the x-axis. Where is sine, or where are the y values less than, I meant that to be negative 1/2. Where are these values less than negative 1/2? Well, less than negative 1/2 is all of these values. So yeah, it's this one interval that I could state going from this angle of 7 pi over 6 over to this one at 11 pi over 6. Okay, and so bottom line is those angles right there that I highlighted in red as being the solutions are the same as these angles that I've highlighted in blue, like that. Well, we've got about 15 minutes left. I think I'm going to do one more of these problems, and then we're going to call it a night. Let's do this one. Yeah, this one, I'm going to show you this one because it involves a double angle. Oh, and it says find all exact values. So I think what I want to do on the exact values, I don't want to do the double angle one. I want to start off with a simpler one. I'm going to do number 7. It says find all approximate values using a calculator. So they are not restricting our solutions to be between 0 and 2 pi. And you may say, well, how could you list an infinite number? Well, I'm going to show you. I can still give an answer that represents all answers, an infinite number of answers. And I want to show you how that works. Now we're going to use, oh boy, we have to use a calculator on this. I did not want to use a calculator. I didn't want to start that off with a calculator. So I'm going to start with, I'm going to go with this one. Yeah, this one will be fine. So I'm going to solve for sine, right? So I'm going to isolate the sine squared. That's going to be 1/2. It'd be 2/4. Add the 1 over, divide by 4. I have 1/2. I'm now going to square root both sides. So when I square root sine squared, it gives me sine. This would be the square root of 1/2. Well, that's 1 over the square root of 2, right? I take the square root of the 1, the square root of the 2, I get that. I rationalize the denominator, I get that. Root 2 over 2. So I'm trying to, and it's a plus or minus. Don't forget, when you introduce a square root in the process of solving your equation, you have to include the idea that there's a positive and a negative value to that. So we got positive and negative. So here's what we are considering. Sine theta is plus or minus root 2 over 2. What I'm going to do is I'm going to list out all the angles within the unit circle for which that is true. And those are pretty easy because those are going to be on the middle quadrant angles, the pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, because sine is going to be either root 2 over 2 or negative root 2 over 2. Those are the 4. But remember, I'd have to continue this list because I'd have to give then all the coterminal angles to each one of those. But one thing I do know about this particular solution is that what is the distance here between each one of these? In other words, what am I adding each time? Aren't I adding 2 pi over 4 or pi over 2 every time to find the next answer? So I can really streamline this to give all values that would be solutions. I can just say, let's start at pi over 4, and we will add pi over 2 times n, where n is an integer. What are integers? All positive and negative whole numbers, no fractions, right? -3, -2, -1, including 0, and then positive 1, 2, 3, 4. And there you go. So you pick an integer and stick it in for n, and that will be one of the solutions. That gives me all solutions. Now let's see how this answer looks down here. Yeah, there's their answer right there. They said or. Yeah, so pi over 4 plus pi over 2 times n. Now, I said that was going to be the last problem. I can't leave that to be the last problem. And I'm going to work another one that would be all solutions. Boy, they really like that double angle right there. I think I might have to do it. Well, maybe not. Yeah, all value. No, that's going to be the same situation. Boy, they really want to do the double angle on those. We're going to do the double angle. They want us to do the double angle for some reason. Okay. It says find all exact values using the unit circle. Well, what I'm going to do is isolate the cosine 2x first. I will subtract 1, divide by -2. Gives me cosine of 2x equals -1. Well, I'm going to deal with the fact that it's not cosine x, it's cosine 2x after I just simply list out what my solutions are for the cosine of an angle. Doesn't matter what is in here. The question is when is the cosine of an angle -1? Right? The angle happens to be 2x. Well, cosine is -1 at one specific value within the unit circle. And that value is pi, like that. That's it. Now, let's consider this. So before I divide this thing by 2, because what I would do here to solve for x is I will divide by 2. Well, within the unit circle, that's the only location, but all of the coterminal angles have to also, all coterminals to pi also have to be solutions. So therefore, I would say plus 2 pi n, or n is an integer, those would also be solutions. And that would capture all of the solutions. But one last thing, I need to solve for x not 2x. So I will divide by 2. That will give me all solutions. That wasn't so bad. Let me see. Let's make sure that's our answer. Pi over 2 plus pi n. Yeah, that's it. All right, there's a little bit more to them. That is finding all exact values. It's just one of those kinds of problems that you have to work many, many examples until you see kind of the whole breadth of things that could happen to you when you're trying to find all exact values. All right, and hopefully in class you'll do more practice on that. Well, that's going to end it. Thank you for attending. To my one student, thank you for coming. And I will see all of you hopefully next week at Mr. Rich Q&A. Have a great week.